Hi, my name is Roger Williams, and this video is entitled Rain, Google Columbus. And this is the analysis portion of this video. This is another video in the Congruent Light series of videos. And Rain, Google Columbus is a research question and a prototype of a research question. Now in the future, when we want to do research, we will possibly look for correlations. Correlations are a statistical measure which can be calculated as just counts. We are told there are many correlations among many far-flung statistics, such as between the number of plastic cups we use and icebergs in Antarctica, for example. So what's the hypothesis? This research question can be formulated as, how many days in the first half of 2009 did the stock price of Google decline on the same day as it rained in Columbus, Ohio? Anybody want to hazard a guess? Now I read that the researchers who are kids now will not need to look this up. They will just Google this. The only problem is you cannot Google this. The promised semantic web is supposed to provide this, but someone will have to write the query. Now the Mathematica of today is a type of semantic web application. And this presentation will show the analytical results of this research and a tool that can be used to answer questions in this class of questions. The succeeding video shows the computational derivation of the analysis and the tool. So let's jump in. We're going to look at some graphs to glean the answer to our research question. We can guess that this is related to financial data and weather data. So first let's look at the price chart for Google for the first half of 2009. So I'm going to grab the financial data for the stock symbol Google. And it wants me to initialize some things here. So you're watching live. And then I'm going to make a date list plot. And so here's a plot of the first 6 months of 2009 with Google stock price. You can see that it bounced on the lows during this stretch, and it achieved a high during this stretch. And these are all the various prices. Obviously, it came down quite a bit. Now, the daily fluctuations we really have to look at, not the actual raw price and the up-down. And this code comes from a derivation script, so I'm not going to go over it right now. It computes the daily fluctuations. And here's some examples. On January 5th, it was up 6.73. January 6th, it was up 6.01. January 7th, it was down 12.05. And there's, I guess, maybe 120 trading days in that period, in that 6-month period. So let's look at a plot of these, and the daily fluctuations are going to look different because zero's in the middle. And then here are the pluses and minuses of the daily fluctuation. Now we can join these points. I'm not sure this is any more illuminating as far as a graph, but you can see them joined here. We use the joined option. But we really just want to look at the down days. So if we look back at the data, the second entry in each one of these is the amount, up or down. So if we select out the ones where it was down, that should be the list we want. And we'll put it in a variable here called down days plus the amount down. So here's all the down days. January 7th, January 9th, January 12th, February 13th, all the down days. Now let's put these on the same graph with the fluctuations. And so here's the fluctuations in purple, and then the blue are the down days connected all together. So in the up days, there's no line. So that's these two on the same graph. And let's switch over now and look at the weather data. So here's a small routine, which is covered in the derivation, to dump clean, so it takes out the missings, and do a sum of the daily precipitation in Columbus. And again, this is derived and explained in the derivation video. So that's just a small routine. And so what I'm going to do here is take all the down days, the dates of all the down days, and feed them into this code right here, daily Columbus precipitation. And I'm going to get just a shortened version of it. So let's take a look. And we initialize the weather data. And it looks like it's still running here. Did it do it? Oh, here we go. Yep. So this is the precipitation on each of the down days. And you can see here that probably there's about 45 down days. And this is the precipitation in Columbus on each of those down days. Now it turns out that we want to sort of take out the light rain days. Some of the days, is it still here? It should still be here. Some of the days, it was either 0 or it was very small, very light rain. So we're going to take out the light rain days by only selecting the days where the total rain is greater than 1/3 of an inch. So we'll store that into a variable called down days when raining. And so assuming we're going to connect to our database. So these are all the days where Google was down and the rain in Columbus was greater than 1/3 of an inch. On February 11th, the rain was 7.35 of an inch. So we're getting pretty close here. So let's combine the down days plus the amount down with the fluctuations and with the down days when raining and join those three. It's just a little kind of becoming a more complicated graph now. So the purple are the fluctuations, the blue are the down days, and this brown line are the days when it was raining greater than 1/3 of an inch in Columbus. So let's take out the fluctuations. This is a little bit of a busy graph here. And you can see what we're left with is just the down days at the bottom, and at the top, the rain when Google, rain on the days when Google was down. So the answer, the question again, how many days in the first half of 2009 did stock price of Google decline on the same day as it rained in Columbus? The answer is just a list of the down days when it's rained, the number of them. And we find out that the answer is 26. Now we made a tool to give to the researcher who was interested in this, and the tool covers more stocks, more sites. It always defaults to Columbus. We kind of called it count days at a certain. So to wrap this up, I actually made a little tool that allows you to select. These are 6 stock symbols, and then also 6 weather stations using the manipulate function. And this will probably take just a minute to run. So there were 10 days when Microsoft Corporation declined and it rained its station in Dallas. So obviously you could pick multiple stocks, multiple locations, and this piece of code here will run the research question. So it's still running right now. So there were 8 days when GE declined and it rained at KDAL. Now, what do we talk about? Sample future research. How to access financial data and filter it. How to access weather data and filter it. How to combine and correlate these 2 types of data. What do we correlate on? The date. Some graphing functions, and how the code from the analysis came from the derivation. So I'll see you in the derivation video. Now, thanks for watching.